This is a companion video for Exercise 12, Environmental Control, the building envelope. Um, you will have read the chapter and had the lecture on control layers, and we're applying that information to our digital twin model using Climate Studio. I definitely need to reinforce, we talked about this last week or a previous week, but it's very important that you understand the energy flows chart or energy balance chart. You'll see this all the time once you start getting into this, and it's a very powerful tool. Essentially, what we have here is a graph of energy use for a building. It's divided into months, January, February through December, and each month the energy use projections for each assembly or component or type of heat gain or loss is color coded. So, for example, people here is this sort of tan color. And we're always going to have heat gains from people because we give off heat. The yellow is lighting. That's always going to be heat also. Infiltration, the purple here typically is loss. But in the summer we get some loss, some gains from infiltration because the air is hotter outside. So you need to understand how this works, or what's being displayed here before you can use it as a tool in Climate Studio. But so the idea is that we're dividing up the monthly projected energy profile, and most of these colors or these components represent passive inputs like people or lights. The envelope is this light green. And so we'll have a certain number of gains or losses from those in a given month, and then typically we will have to make up then the difference. So in January we have a lot more losses than gains, and so we have to heat, which is what the red bar denotes, and that's how much heating for that month. In the summer we're having to cool, which is with the blue. Okay, so we're going to use this chart in this exercise. So let's get into it. This is the assignment itself. I'll come back to that at the end of the video. So here's the digital twin model I've been playing with all semester. Let's remind ourselves that I've organized it into the assignments, and so that I can easily access different sets of layers and turn things on and off and understand the flow of what I've been doing with my model. I started with a site study and have a bunch of radiation map studies from just the site itself with our cube as a volume on it. I have also surfaces that I used as shading that were emulating something that was happening outside. I have a ground plane, and I did a series of simulations to learn about the amount of sun hitting, or the amount of solar energy hitting my cube based on different variables I change. Then we talked about heat, and so we have a series of simulations where we're looking at the amount of heat inside the building with different glazing amounts, and let's change this to different glazing amounts, different solar heat gain coefficients, all things that we should know about, different colors inside. Then we did a week on solar rejection, and in the digital our digital twin model, we focused on shading, and so we had different shade. Well, we actually focused on some other things too. I'm just making the point that we've been going through and using the same model, running different simulations to try to understand whatever fundamental we were learning that week. Sometimes we were going outside and trying to emulate or use this information to make physical measurements also. And then what we've morphed into near the end of the semester is just doing digital twin studies in Climate Studio, and then next week we're going to go outside and sort of bring it all together. And that's the second half of the assignment for this week. Um, okay, and then we just to finish this off, we did a bunch of simulations for daylighting, where and we also did glare studies, and I'm not sure if I showed you radiance renders or not, because it's that's a little bit more advanced, but we can see where the daylight is coming from, and if we have glare, we can try to physically block it. In this case, we started using light shelves, and or I did in my tests. I also had a different tried two different window layouts or glazing layouts, and got very different results. Anyway, there's a whole video on that. So the point is that I'm using the same video or the same model to run all of these simulations, and that's important partly because you're going to be doing this in other semesters, and also because as you try to make a final design that you're going to test outside, hopefully you have an organized model that you can come back and look at the simulations you've run and try to make intelligent decisions about the next steps. All right, so this week though we're going to focus on the building envelope, which that's the topic of the week. So how do we set up a simulation in Climate Studio so that we can so we can design an envelope? So in our drop down, and by the way, of course, we've used, let's see, the site analysis tool, we've used daylight, we've used radiation maps. I've done radiation rendering and glare, but I'm not sure if we did cover those in class or not. And so there's another drop down called thermal analysis. So what we're going to do is set up our model, our cube model, or half cube. Let me turn off my glass here. So here's my cube. I'm going to set this up as what's called a thermal zone. That just means it's a box of air that has a specific heating, cooling, and actually fresh air requirement if it was an actual building. In our case, we're just going to use it to focus on the envelope. So the first step I have to do is I go to my thermal analysis drop down, and I'm going to create a thermal zone here. So I'm just going to select my cube. And by the way, if you have you don't want, this just needs to be an extrusion. So if you have your more complex cube that has the thickness of the of the particle board or the chip board or whatever, you don't want to use that. So just come in and make a new extrusion. You use that as your baseline, and then just make an extrusion around that represents the exterior of your entire cube. Okay, so and technically it would be the interior, but it doesn't matter. It's a very thin cube. Remember, we're also using the foot version. So this is an 8-foot cube, not an 8-inch cube. 8 feet, right? Okay. So I'm going to select my cube, come to this zone from template icon, hit that, and you'll see that this dialog opens up. I'm going to name my zone the cube. You can name it whatever you want. You can't have a space. The cube. And what we have here then is a bunch of settings that define the thermal properties of the space. Now this is a much more complicated set of variables or a much more detailed set of variables than I'm going to cover today, because it's basically a lot of next semester is in these settings. But I have to set everything up, so you'll see some things that we haven't covered yet. But the point is here that we can use templates in Climate Studio. So if you start a thermal zone and you say OK, it will have automatically set something up for you with settings that were preset. So I'm just going to say OK, and so now I've got a zone. I've got automatically windows showed up. That's because there is this automatic window to wall ratio tool we can use. It's set at 0.4, which is the maximum that you can in the prescriptive code that you can have on side of a building, a facade, is 40% of the surface area of that facade can be glazing. So that's why that's the default. But let's actually go create a template ourselves that we can then make that you can just copy the settings that I'm going to put in here. So if I go to this little library icon up here, we have all of these. So we have what are called zone space use templates, and this is where we're going to define the loads inside the space. So it's not going to be the construction, the envelope yet. We have to set up some basic parameters to run a simulation that are dealing just with the space. So I'm just going to, you can just pick any template and select this button down here to copy it, and then it'll make a copy and you can name it whatever you want. I've already done that. And so I have the cube space use template down here. I'm going to open that up and we're going to look at the inputs. So the first thing is what are loads? Those are things that, in this case, it's going to be heat loads on this space. So it's things that's putting heat into the space. The first load is people. That because people are giving off heat, we have to take into consideration how many people we have in the space. So we have an 8x8 square foot space. 8x8 is 64. And this is in people per square foot. If I say, and I'm just going to imagine that there's one person sitting in the middle of the space in a chair, I guess, and that's going to be the occupancy of this one 8x8 space. So I'm going to divide 1 by 64. Oops, sorry. 1 divided by 64. 0.0156, and that's why I have 0.016 here. Metabolic rate is just things we've talked about, and we've actually had this in our psychometric chart. 1 would be sitting still. 1.2 is a little bit of activity, so I'm going to leave it at 1.2. I can set schedules for when this person will be in the space. So I went ahead and set this from 8 to 5. I guess you could set that to whatever you want to. We're not going to have any equipment or lighting, so we can just not worry about that. I've set these to 8 to 5 in case I do want to come back and have equipment and lighting. Lighting and equipment both would be giving off heat if we had them in the space. But this is just our little cube that we're modeling for this, really just to right now think about the envelope. So I'm not going to go into that level of complexity. I'm going to turn off hot water. So that's the loads. That's all that, if you're sitting in this space, we've built our cube, you're sitting outside, one person. This represents what the heat that person would be putting into the space. And there's because we have standards for how much the average person heat is giving off. So we're able to use that in the simulation. I'm going to set my conditioning. So this is just what I would set my thermostat at. So I'm going to set it for 68 degrees, both for cooling and heating. And I'm not going to have any mechanical ventilation. Now that would be a total no-no, but right now I'm trying to make this as simple as possible. Mechanical ventilation we haven't covered yet, but it basically means we would bring in fresh air from outside so that we could breathe in there. If it was too tight, airtight, eventually carbon dioxide becomes a toxin to us if there's too much of it. But so we're not going to have any mechanical ventilation. So I'm done with that, or I'd already set it up, but that's the parameters you would set. So now we have the loads that are being added to the building. We also have actually I'm going to get out. Well, I won't yet. I'm going to talk about the construction, and then I better go out because I'll probably forget it. We do have to have a mechanical system at this point, and so in Climate Studio there's this thing called Ideal Air Load Default. It should be automatically when you created a zone set to, that zone is now assigned to that mechanical system. Just make sure it is. If we edit this, this is a bunch of stuff we're going to learn about next semester, so you can just leave these presets. Without this, we won't get a simulation that makes any sense. We have to have some kind of mechanical system running. This is the simplest one, and that's all we're going to say about it. So it's just going to allow us to run these simulations so that there is a complete set of variables that have been input. Okay, so now I can start thinking about my envelope. So let's, if I edit this zone, I can, there's already been a space use and a construction use template assigned. But like I said before, I've actually created my own. And so if we go back to this library and click on this second tab, Zone Construction Templates, you could pick any one. And you probably want to choose one that says CZ4 because that's Climate Zone 4. But really, you're going to set all the parameters yourself. I did this, and I have the cube construction. I'm going to edit this and show you what I've got as settings. This gets a little bit involved, so just bear with me. Well, not really, but I mean, there's some steps to it. So the first thing is the envelope itself. And so we've learned about that, and we know that we have 4 control layers that make up our envelope. They typically, we can think of them as wrapping the structure at the simplest and most efficient configuration. But if you think about it, if we have an actual building, and even if we have the exact, like our cube, we have just particle board that's making the whole cube. Well, the roof and the walls are different because there's going to be a different amount of sun hitting them. There's going to be the roof is going to, since heat rises, more heat will move through the roof than through the south wall, for example. So we have to, all of these component or these different divisions here with they have little icons describing where they are in the building are just different conditions that your envelope that you would need to define for your envelope in order for it to be complete. Since our envelope is so simple, we only have to choose 2 of these. We have to design a roof and walls. So I'm going to click on roof, and you see that when you do that, you'll have some other other template that's been chosen as a default. What you want to do is go to default construction. So just scroll to the top. If you select that, you'll see that it's just concrete. The reason I'm choosing that is because it's a construction that has just a single layer, but you can really actually pick any of these because you can then completely adjust it. So pick a template and again copy it. So over here you copy it. When you do that, you'll be able to name it. And so I have several of these I've named. So I did a cube PB roof. What does that mean? So let me edit it. I have what I did is I just selected the concrete, which was in the default, and then if you just double click on a material, this material library comes up and you can pick something, or you can add a material. Okay, so I'm going to delete that one I just added, and if I just well, actually maybe I'll just that'll be a way of showing it. If I click on a default material, and I'm going to put in particle to see if there's any particle board, because I think that would be, yeah, here's some. This is what I ended up using, I think, was the medium density particle board to represent our chipboard. You can look around and see if there's something else that made sense to you. If you have a 3D printed model, you might want to find a different material. It's going to make a difference, but not a huge difference. It's mainly the thickness that we're talking about here, and that these are not materials that are really designed to be insulation. Okay, so I've picked a material. I'm going to delete this now. And then I have to pick the thickness. This is in feet. So let's think about this for a second. If I have, I think that our particle board is about a 1/16 of an inch. So if I do 1 divided by 16, that's 0.0625 of an inch. But since we're not doing this in inches, we're doing it in feet, we would multiply that times 12, right? Or I'm sorry, we would have to divide it by 12 in order for it to get down to a 1/16 of an inch. However, since we have we've actually scaled up our model to feet, this will work. So this 0.0625 is the right dimension to represent the relative thickness of that particle board. So that's why I've got the 0.0625. I say OK, and now I've got a roof portion of my envelope that I can choose. I did the same thing for walls. I actually made it the same exactly, but I wanted to have 2 so that I could apply them in different conditions. So walls and roofs. Okay, so that's the envelope, the assembly of the envelope itself. So we talked about what do we have? We have liquid water, water vapor, heat, so thermal, and air. The only thing that we're going to define in this model is heat and air. Water vapor is going to be dealt with our mechanical systems, and with other detailing. We're going to assume that we've correctly detailed it. It won't change the thermal performance considerably where we have our vapor barrier, or how we have a drainage plane that's keeping liquid water out. So this is a thermal model. So we're just focused on uh, the basically insulation, the materials that are placed that will have heat flow through them, and then also air infiltration, air leakage, so we see how much air is circumventing that insulation and causing heat loss or heat gain. So in this case, we're going to leave it. We're going to say zero point 0.2, and this is CFM cubic feet per minute. So that's a volume of air per square foot of the exterior volume of our building. So this is just a measure of how tight we have made our building. And so when you're actually dealing with your physical model, you're going to want to tape it up and make it airtight if you're trying to make it the most energy efficient. And so this is a decent air infiltration setting, but it's not the best. And so we're starting with that. The exterior window, since we have chosen the window to wall ratio option, this is going to give you, we can select our exterior windows in this dialog. Later you'll see that I'm going to actually add windows if I get that far in this video, and then you'd have to do this workflow someplace else, but it's the same exact thing. I'm going to start with default glazing. That's really actually pretty close to what are actually if you're using the plexiglass like I purchased. We have a solar heat gain coefficient of 0.9, a U value of 1, which is an R value of 1. Pretty bad, but still something. And then a high, and this is good too because this is the same TViz, the visible transmittance, as we were using in the daylighting work that we've been doing. So, okay, so I'm picking the default glazing and saying okay. So now I have, let me just go back in there. I have my envelope completely set up. You don't need to worry about the settings tab. You don't need to worry about, I would just turn off the internal mass. All right. So and then I would say, I've defined my template, and then I would come and apply it to my zone. So I've got a zone here. If I edit it, I can now say, let me go find that, the basic template that I created. If you can't see it, sometimes because like I've got you might have this is basically just a filter for because we have a lot of templates we can choose. You can always just go here, and I put mine in other, which is a small list, so that's helpful. But if you don't see it, if you go to any building type, it should be there at the bottom. Anything you make, it's put at the bottom of these lists. Okay. So then, if I run this, by the way, you get a DOS window that shows up to run it. I get an output, and I have. By the way, you'll probably you'll see this initially. This is energy use intensity per month with some of our components here. You would want to switch to the energy flows, and so that's where we can actually make an assessment. I'm just going to delete this now. So I mean, we've set up the model. You know everything you need to know to set it up, except for maybe changing windows. So let's just look at some results and see how we can now iterate. So I'm going to delete that. Say OK. When you do that, let's see if it does that to me. Yeah, it screwed me up. So Climate Studio by default organizes simulations by the date and time that you created them, and so it puts them in time order. I often, that's clunky to me because I'm going to try different things and come back and I want to have them in an order that I can understand and remember. This is a good habit to get into. You may not use this model in the future, but if you've got a model of your studio project, for example, or anything you're working on, if you organize these things well, you can use it as a resource later and come back and look at it and maybe work on it again, or just remember what you were doing and see what your results were. If you don't organize it, it'll, in a few months you won't remember what you did probably, and it will just be useless as something to go back to. Anyway, so if I double click on the date to reset it, and then now I'm going to be in name order, and if I can either go in reverse chronological order or chronological order. I'm going to go in reverse. So now I've got a bunch of simulations that I ran in the order that I wanted to set them up. So let's just go through these, or some of them at least. So the first one, and here's my little code that I'm using. You should have some way to understand. You may remember that if in other simulations you could click a little eye icon here, and it would give you some information about what settings you use, what layers were on, or whatever. You don't have access to that in a thermal simulation, and I could talk to you about why. And this is a whole world that we're getting into here that I'm just trying to keep very simple. The data is there; it's just harder for you to get to in a way that would help you. So it's really important that you make these clear so that you understand what you're doing, what has changed. There is one way that we can look at them, and I'm going to go ahead and show you that. If I select 2 or more simulations and I select this compare chart or compare graphic, then I can I get a comparison that I can actually go to an energy flows chart that's similar to what I'm looking at, and there's a way here to find out to interpret what you've changed. So that's one way you could do it, but don't worry about that right now. You're not going to want to do that. If I hit the double white arrows, that clears the simulations I'm looking at. So the first one I ran, I'm saying because I've got all my simulations from the semester in here. I've organized them in a way that I can easily understand where I am. So I'm on envelope. PB is particle board. I'm saying that I set infiltration at 0.2. My glazing is default. Window to wall ratio of 0.4. The things we set up. And so here's my baseline simulation. Make sure you're in IP kBTUs per square foot. If you're not, go to this tab and click here. If it says SI, you need to click on that. That'd be IP. SI is metric. IP is inch pound, which is what we use in the US. So we have a site EUI, energy use intensity, so the amount of energy we're using per square foot, that's why it's intensity, of 515. That's the only number I want you to look at in these outputs right now. And then we've got this nice chart telling us what part of our cube is responsible for each of those gains and losses over time. Over each month. So we can now go, well, what do I want to do to improve this? Let's see, what was the first thing I did? Oh, yeah, well, the most obvious, even though it's not it's right now it is actually. I'd say the envelope is probably the largest effect. The way it's larger, so the light green is envelope. Let's make sure we remember these colors. Light green is envelope, and dark green is windows. So we've got a lot more loss from the envelope in the winter, but we've got a lot of gains from the window. The envelope meaning the opaque envelope, the stuff that's not windows or glazing. And then in the summer we have a lot of gains from the glazing. But I think a good place to start is by insulating the envelope, because obviously that would be what you have to have insulation in contemporary buildings, right? So if I do that. And how would I do that? I would come back. I would go to my zone, edit my construction template, which is where they have the insulation. And what I did is copy each of these and just make new ones. Or you could just edit these, but I think it's better to have them because you're going to want to come back to it. So again, if I click on this and I copy it and I make a new one, what I did is I made a insulation for roof and walls. I'll just show what it is. Let's double click on it. Oh no, I have to edit it. I added rigid foam EPS insulation, and 0.167 is about 2 inches. This is a good moment to say this. I'm going to try to get some 2-inch foam and bring it to class in Old Westbury, so that when we're doing these tests that you might have some extra around. But if you want to do this yourself, I would get together. You could buy a 4x8 sheet. Well, I haven't bought any in a long time. I'm probably dating myself, but it's not going to be crazy expensive. $25, something like that, and that's huge. 4x8 feet. So the entire class could cut that up and use it. You could get smaller ones, half-inch thick or 1 inch thick. But anyway, so I'm picking something that I know I can get at Home Depot or Lowe's, and I'm saying I'm going to use 2 inches, which is a typical thickness. That's probably the thickest one you'll find at Home Depot or Lowe's. There'll be half-inch, inch, 2 inch. There might be slightly larger. And they just come. They're usually blue or pink, and they come in big. That's just different companies. Um, and you can cut them very easily. So anyway, that's what I did. I just insulated my building with 2 inches of EPS foam, um, and then I ran that with everything else the same, and I got this result. So a drastic drop from 515 to 378. And if we go back and forth, so did this light green get smaller pretty much across the board? Yes, it did. So, and it's more in the winter than in the summer. That makes sense to me because, it's we have a bigger heat load. The temperature is much closer to our indoor temperature in the summer than in the winter, so we're not going to have as much loss through the envelope as we do in the winter in the summer. Anyway, so my point is, I made a change that makes sense. That I made a change that I thought would help. It did help quite a bit, and I can see that it makes sense what happened. And so then I just went and I continued this process. I decided to have only I tried only southern glazing. That helped quite a bit because then, so let's see if I do that. Let me show you how you can do that easily here. If I go to this window to wall ratio, and right now it's uniform. If I change it to directional, I can make all of these 0 except for the south. Oops, made the south 0. And now I only have the glass on the one side. And so I can run that, and I did, and I got it. Because, I'm thinking, well, and why would that be something might be a good idea? Um, well, if I know that, let's just go back to, the sun. If I look at the sun for my climate, I know that I get the most sun, and I could look at my radiation maps from an earlier simulation. I'm not going to do that. Sometimes I have a lot of simulations, and if I start going into the earlier ones, it slows down. By the way, if you ever get to where you've got a lot of simulations and it's taking a long time to go, like if you click on one, it takes a long time to click on another one. If you just save and close down and open up again, for me, it resets the cache, and it seems like that works. But my point is here that I'm reminded that, oh yeah, I'm going to get more heat on the south than anywhere, so maybe that would be a place that I would want to have glass, because if I'm trying to get some heat gain in the winter. So if I'm going to keep it somewhere, maybe try it on the south. So that was the idea behind it. This is a way to learn about your climate and your building context. So that's the whole point of it. So that was the idea behind that. I rotated it 90 degrees so that this piece of glass is to the east. That should make this higher, this side UI, because I'm going to get more heat at times that I don't want it. And it did quite a bit more. And you can see that I'm getting more heat in the summer. And if you think about the path of the sun, you'd understand why on the east side that would be true. By the way, you notice it didn't change in the graphics window. These simulations are not tied to the graphics, so you just have to remember that. And if you're trying to make graphics from that go with your simulations, you just have to generate them. Like I could set it up again to be the settings that I did for this simulation, which is just rotate the whole thing 90 degrees, and then I could take a screenshot of that or however I want to do it. But then the point is, I just kept going with that process. I did things like I tried, because then I thought, well, okay, great. So I could keep going along these lines, but do I want to have it where I only just have south glazing in this little space? Seems like I would want to have more, on the other sides. And so I tried a different glazing placement. I'll show you what I did there. Actually, there I switched to physical glass. So let's just do that. That's a good thing to do here. So if I want to actually not do these just percentages of glazing, I can add glass. So I have some glass here. And it remembered that I had, because I've already run this before. But I'm going to go ahead and delete these so that I can re-add them. So I'm going to delete these 4 windows in my zone. So delete, yes. And I'm going to make this 0 just so we don't see that. Okay, so I have these this glazing setup that I want now to be my actual glazing from my thermal zone. So if I select those objects, so all my glazing is selected, and the icon next to the add zone is add window, and I'm going to keep my default glazing like I had for the automated glazing that I put in before. Now I have actual glazing that I can run a simulation on. I did that. Then I tried overhangs. Let's add an overhang. Okay, I added, yeah, quite. This is that's interesting. I think I moved this at some point, so I'm going to go ahead and move it right now just to be, so it makes sense. Okay. To add shading, it's already here. There's a little bit here because that must have been from a previous run. Let's say I want to have all 3 of these surfaces as shading. I select them. This icon here is for shading. Select shading. It's there now. I don't need to add a material to it. This will now shade. It will block the sun throughout the year and have an effect on how much sun gets into the building. So there's a number of things you can do, and you should just use your knowledge to play around with this and try to get these the balance here. Basically, try to get this as low as you can get it, but using not ridiculous settings. You want to use settings that you think are realistic. I will make a point right now, though. So let's say right now, so I have this this run right here that we're seeing is let me see if this is right. Yeah. So this is when I adjusted the glazing and ran it with the default glazing, I got this side UI. But I see here that I don't like this pattern because what it's saying here, the dark green is windows, is that in the summer I've got a lot of gain when I don't want gain because I have a cooling load. And in the winter, I don't have a whole lot of gain, but I have losses. I'd rather flip this around to where I have lots of gains in the winter and not so much in the summer. So one way I could do that is by adding shading. And so if I add shading like I showed you here. I added this, and look at I definitely get an improvement in that shape here, but I actually get a higher side UI. And this is one place why I am really pushing that we early on, like where you guys are, we start learning simulation, because the rule of thumb would tell me that this is better. And I'd be all proud of myself if I could even get these numbers without seeing this final, if I were trying to design this space and I was trying to drop my side UI and I saw this profile, I'd think, well, I'm going to get some shading here, and I'm going to look at I'll look at the solar path, and I want a lot of shading on the east and west because that's really low. Let's just do it again. It's always so easy to go back to this. It's I'm going to get all this in the summer. This little bit of shading is going to block the sun on the south, but I'm going to need a lot of sun to block it late in the day. And same thing on the east side. I mean, late in the day on the west. So, and that's why I actually chose this particular layout of glazing so that it's more shaded. Maybe that's mostly for daylighting. But I see here now, and by the way, I'm not saying that this is accurate. We're just gaining information and learning things. But at least puts into question whether or not my common sense approach to shading works all the time. So if I come back to this and I look at what I'm saying is that I'm actually, my shading strategy seems to be working, but what's happening is the devil's in the details. I am dropping the amount of gain I'm getting at the highest point in the summer, but I'm also losing a little bit. Like if you click back and forth, you see this in April went up a little bit, and in March it went wait, let me. Like I'm basically what I'm saying is that I'm getting, or like, I think it's the big one that I'm gaining more in certain months where there are shoulder months where I maybe don't need, where I don't want the extra gain. So it's very detailed how this actually works. And if you have a situation like this where you can add it all up through a computation that a computer's doing, you get a provocative and much more probably accurate result. So all I'm saying here is that in this case, at least, it doesn't look like adding this shading that I've chosen here is improving things. It's actually making it, 2 or 3% worse. Um, then another one, the last, well, there's two more that I'll talk about. So and well, in the next one you actually could maybe do. So far, all of these things are things that you could do with your physical model because we've got glazing that has specifications that we think are relevant to our plexiglass. We can surround our building with rigid insulation with a hole cut out of it for the so that the light gets in and the sun gets in through the glazing. We could add this shading if we wanted to. Um, and one other thing we could do is we can adjust the air tightness. And so if you look at this here, um, we've got a lot of leakage from air. Another thing I should say, these simulations are designed for large buildings. So this is a game we're playing here. And that might even be an argument for what I'm seeing here. Maybe if I had a larger building and a different dynamic between the tiny little space that's inside here and the square footage of the exterior facade. Anyway, so these, no one's ever going to really do a simulation like this for a little tiny building. We're using it as a learning tool and to try to start creating digital twins. But I'm not saying it's completely accurate. However, infiltration is going to be huge for your little cube because, oops, I don't want to click on that yet. Because think about it. So we have it. So the opaque area is where we're going to have our insulation, the white there. And if we spend a bunch of effort to make that to surround this insulation, but then we don't, which most of the time I've seen with you guys is the case. You've got your particle board just loosely taped on here, and you've got a big gap at the corners here. A lot of air is going to circumvent that foam, and you're going to get, so if it's cold outside, that air is going to go in and it's pretty quickly going to fill that little space. So you really would need this to be airtight for it to be energy efficient in any way. Much more airtight than if it was a really big building. It'd be more forgiving because you'd have a lot more volume inside per square footage on the outside. We've talked about that before, the surface area to volume ratio. So bigger buildings can have more leakage and not be affected as much. So I went and adjusted my infiltration rate, and you can do this also. So I edited my construction template, and I set it at 0.05. 0.05 is a very low but achievable in a real building infiltration rates, more like a passive house level. But you could definitely achieve this if you were careful by taping up your joints, because you have a very small envelope, and you could, and there's ways we could test it, and whatever. But so if you want to set that variable at 0.05, you're welcome to do it. And I did that, and I got. Let me just show you the results. So I went from now I'm going to compare. So I'm comparing it actually to this. This has the same window setup, and there's no shading. So let me turn off the shading just to be clear. So I went from 378 to, oh no, actually I'm comparing it to this glazing placement. So this is the same glazing. And then if I change the infiltration, I'm almost cut it in half. It's a drastic difference because that's a big chunk of the losses. It was mostly losses in the winter. All right. The final thing that I did was I used high performance glass. Now you would not be able to do this in your actual physical model, so you may not want to do it here, but you can if you want to. And since these are actual pieces of glass that I've placed here, not the simulated ones, I have to come to my actual zone. I mean, they're all simulated, but I'm saying these are on this layer here, right? So if I want to change their performance level, I have to select them like this all together. If I edit, I can come to this default glazing. And we've talked about glazing before, so you could be able to choose. Like, do you want you could make a lower solar heat gain coefficient. You could choose a really low U value. If you click on the columns, it organizes them in chronological order or number order. So I can come and find very low U value um, configurations, and then we see that we get this section here just like we did for opaque envelopes, showing the glazing, talking about the properties. These are all things that you should be able to understand from what we've talked about this semester, and so you should be able to intelligently choose a piece of glass or just an experiment, try some different ones, and that I was I was able to get this to go down by choosing better glazing, but again, I won't be able to emulate that in my physical model. I'm not in my physical model. When we're doing the actual testing of these, we're not going to try to get anything. This is an annual estimate of energy use. We're just going to try to get the temperature to go down, or go. I'm sorry, to be higher inside than it is outside by our configuration. Hopefully, it's a nice day during class and it's cold next week, and we'll be able to learn something. Okay, so. That's all I need to. That's pretty long, probably. I wonder how long this is. I don't know. Let's see. Um, that's how you set up the simulation. So let's just look quickly at the assignment. So what I've done covered so far is the baseline model, the iterative envelope, the data and analysis, just what we've always been doing. You should make a little table. It'll be obvious. You'll take all the what was the insulation value of the opaque portion of the envelope, what it was. You could probably describe it briefly, just in a spreadsheet. So just a couple, particle board. How thick was it? Then another run, add insulation. However you want to do that. Then put in the EUI for each run. I would then pick a baseline, which is the lowest one. I mean the highest EUI, and then just divide each simulation by that baseline, and then you'll get a percentage of change from that original. I described that here, I think, in this paragraph. Okay, so that's the main thing you're doing this week in class. At least you want to get most of this done in class so that you can ask questions. Then for next week, you are all you need to do. You don't need to do any other work in Climate Studio, or really much work at all, except for think about the entire semester. You need to pick a baseline. So what you're going to do next week is take your models outside. If hopefully it's cold and sunny, and we're going to do a summary set of tests on a baseline design. So something that you started with, maybe would be that first week where we just had you had all the blanks in place, and you had one facade that had windows or openings cut into it. Maybe that'd be your baseline, or whatever you want to make a baseline. It doesn't matter, but we're going to use that and do all of a series of tests that I'll have everything. Basically what we've done before, a few other things. And if you're on Old Westbury, I'll have other sensors you can use. If you're in Manhattan, you'll just be using your app, your Govee sensor, and your apps that we've introduced in other assignments or exercises. But the point is, then you need to have a final design that you think is going to perform well in all of the different categories. So you need to think about what you've learned and create a design that will perform well in daylighting. We'll be able to get a difference in temperature that if you can look back at the shading lecture, and the idea would be that we would decide whether or not next week at this time of year would we want heat in the building. Probably would. So we don't want it to be that our shading is going to be dropping the amount of sun that's getting inside. So we could actually measure that. You could put your shading in place, and we could see if it with and without it, if it changes the amount of sun that goes inside. So you at least need a baseline and a final design that you can configure quickly between the two. Or you would do the baseline, we'd do all the tests, and then you would do your final design and do all the tests. We're going to have a mirror board with a spreadsheet and placeholders for images that you're then going to, so you won't need to do any calculations or anything. You're just going to put your results into it, and we'll have a nice sort of summary of what we did with these models. You could also then, if you don't want to just, if you want to be a little bit more in depth, or even, well, I'll just say it. So you could have interim iterations between, because it's so easy to reconfigure your model. So you could say, well, this was a good daylighting design, this was a good thermal design, and you could do them separately, and then have a final combination, or just have the combination at the end, however you want to do it. But we just want to go out and try to use everything we've learned to learn something about two versions at least of our model. One that's just sort of was it's a baseline, and we're not thinking about the variables. We're making something that we thought was pretty. Basically, what you guys did that first week, or the first time we went outside with our cubes, and then something that's informed by what we've learned this semester. That's the concept. All right, okay. That is my attempt to help you with this exercise, and I will see you in class, or you'll see your professor in class